Hey everybody, today we're going to be talking about composite figures. Before we get into the lesson, I want to do a quick review of some of the area formulas that you're going to be using today. And what we're going to do down here is drag these cards to match them with the areas that they should be with. And to start off, we have area of a rectangle. Area of a rectangle is length times width. So we're going to drag this one up to there. Next, we have area of a triangle. Area of a triangle is base times height divided by 2, also 1/2 base times height. That'll give you the same answer. Next, we have area of a trapezoid. Now, this one is typically harder for some people to remember, but I can go ahead and do the circle ones if that's easier since we did those in the previous lesson. We have both the area of a circle and circumference of a circle, and the area formula is pi r squared. The circumference formula is 2 pi r. Anything to do with circles typically has your pi involved. And then our last one is the trapezoid one. If you ever can't remember any of these, you can always Google them for reference. So let's talk about what composite figures are. These are the combination of shapes into a larger shape, like the one that we have here. The big idea is that you're basically going to be able to break this shape into smaller pieces that we do know the area formulas for, and then we can find the area of those pieces and add them together to get the area of the whole shape. Now there are a few different ways we can break up this shape. We could draw a line right here to break it into 2 rectangles in that way, or one right here into 2 rectangles. The one that I would avoid is sometimes people draw a diagonal line, but that is a shape that we don't know the formula for unless we want to break it into more triangles and rectangles. We want to make this easy on ourselves. So I'm going to go ahead and just draw a line right there. And we basically have 2 rectangles here that we need to find the area of. So the one that I see is the easiest to find the area of so far is this smaller rectangle here. The green one, we're going to do length times width, just using a cursive L there. And the length is labeled on the bottom there as 8, and the width is 6. And so the area of the green rectangle is 48. And I like to draw the little area with a circle around it in the center. Put a circle around it so we don't think it's measuring some other length around it. And then we need to find the area of this larger rectangle over here, or skinnier, I guess. And the length and the width aren't super clear. I have this small edge that's the width and this larger one that is the length. But we can use the other information in the problem to solve for this. For example, I know that a piece of this side right here is labeled as 7. And then this one over here, the rest of that wall is 6. And so if I just add 7 plus 6 together, that'll give me the length of that rectangle, which happens to be 13. And then this distance on the top, the whole distance is 13, but how do I find just this little piece right here? Well, some other information is that this is 8. So if I subtract those from each other, that'll give me the distance that's left over. 13 minus 8 is 5. And so we're going to do 13 times 5, length times width for the red rectangle, to get 65. And now I know the area of each of these 2 sections. I can just simply add them together to get the area of the whole thing. That gives me 113. We could label it. These are all in meters apparently, and so our total area is going to be in square meters there. So let's try this one out. I want to break this into 2 shapes that I know the area formulas for. The one that's pretty clear to me is we could do maybe a triangle and a rectangle. We could make it into 2 different triangles probably. Whichever one you want to do is fine. I think I'm going to make it into 2 triangles just because I can see that I'll have the height of this triangle, and I already have the base of this kind of sideways triangle right here. And remember that your base and your height of your triangle need to be perpendicular to each other. So we have base times height divided by 2 for area of a triangle. So for that blue one, my base is actually the 20, and my height is 10. And I'm going to divide that by 2. 20 times 10 is 200. Divided by 2 is 100. So that is the area of the blue triangle. Next, I have this other section of a triangle here. And here's my perpendicular angle that I labeled. So basically, our base being perpendicular to the height could be 12 by 10, or if you want to think of the base being the 10 and the height being 12, kind of upside down, whatever makes sense to you. We're going to end up multiplying 10 times 12 and dividing it by 2. 10 times 12 is 120, divided by 2 is 60. And so adding those two together, 100 plus 60 is going to give me 160 for the total area. So for our next composite figure, it appears we have a half circle and a rectangle that are making up our shape. And for a half circle or semicircle, we're going to use the area of a full circle, which is pi r squared. And since this is a half circle, we're going to divide that answer by 2. And then we'll use length times width for the area of the rectangle. Now notice my answer options over here on the right-hand side. It has pi involved, and so that means that we are going to find our answer in exact form and not plug anything in for pi here. So let's go ahead and find the area of the half circle to start. And we need the radius first. And it looks like the diameter is labeled as 10, so the radius is going to be half of that. The radius is going to be just 5. And so we get pi times 5 squared divided by 2. And that's going to simplify to 5 squared is 25. 25 pi over 2 can be rewritten as 12.5. I'm noticing options C and D have 12.5 pi as part of the solution there, which is a hint that A and B are not going to work out for us. And then we just have to find the area of the rectangle that's going to be added on there. So 10 times 15 is 150, length times width. And so that means we're going to be adding 150 plus 12.5 pi, and that's going to be our solution. And our last problem for now is a situation where I'm going to have to work backwards. The question says the composite shape has an area of 144 centimeters. What is the height of the trapezoid? So trapezoid is a quadrilateral that has 2 parallel sides. Going back to our formulas from the beginning, the trapezoid formula does a plus b divided by 2 times the height, where a and b are the 2 parallel sides. So I wrote that formula on the board, and we basically need to identify what a and b are. We don't know height. We're going to have to solve for that. And I see that my a, the top parallel line, is 10, and then I have my bottom parallel line here, which is not labeled, but it's going to be the same as this distance of the rectangle down here. So the bottom is going to be 14. And the thing that I don't know is what is the area of the trapezoid. I know the area of the full composite shape, the whole entire house, if you will, is 144, but I still don't know what this area is right there. And so I can't yet use it to solve for the height. But the area of this rectangle here is going to help us, because if I take the whole area of 144 and I subtract away what is the area of this bottom rectangle, that'll give me the area of the trapezoid. So length times width, 6 times 14, is going to give me 84 for the area down here. And I know that the whole rectangle, or excuse me, the whole shape, the whole composite shape is 144. So if I subtract away the 84, that's going to give me the area of the roof. So that's giving me 60, and that's the area of the roof. We can plug that into this formula now. So area is 60, our A is 10, plus our B is 14, divided by 2. We don't know H, that's what we're trying to solve for. And this right here, this fraction is something that we can calculate out. We're going to do 10 plus 14 to get 24, divided by 2 is 12. So we have 60 equals 12H. I'm going to divide both sides by 12 and get 5 for our height.